Well, welcome class. This is the new and revised 1-4 Course 1 lecture, and I hope that we have a little bit better luck. My apologies, we couldn't get this up on Thursday, but thank you very much for coming back and giving it a second try, and I hope that this was helpful. So welcome to Lesson 1-4 on estimating with decimals, finally. All right. As we talked about in class, both on Friday and on Monday in class, we have a couple methods of estimation. All right. Now, the classic method that we've known, the tried and true method for estimation, is of course rounding. Okay, and we have our little mnemonic device to help us remember the rule for rounding. If we want to round to any place, doesn't matter whether it's a whole number or round to the nearest 10 or rounding to a decimal place. We look to the immediate place to the right of the place. So let's say we're rounding 348.7, and we want to round that number to the nearest 10. Okay, so right there we're going to look at that place right there. The question is, how do we round the 4? Well, we always look to the right. So if we're rounding to the nearest 10, we're going to look over at the digit that is immediately to the right of it, the one that's underlined in blue. Okay, and as you heard in class, the mnemonic is if that number, the one underlined in blue, is 5 or above, we give the first number a shove. In other words, we move it up. So in this case, the 8 is bigger than 5, so we're going to round to 350. All right. Now, if for some reason that number was a little bit less, let's say it was 342. Oops. 342.7. And again, let's say we're rounding to the nearest 10. So we look to the right of the 4, and now 2, if it's 4 or below, we let it go. And what let it go means we just basically let anything go and we replace it with a 0. So that's 340. So that's how we round. 5 or above, give it a shove. 4 or below, let it go. All right. The next method is using compatible numbers. Now, using compatible numbers is especially helpful when we're multiplying or dividing, although technically you can use compatible numbers just like with rounding for addition, subtraction, multiplication, or division. While as rounding has very specific rules. 5 or above, give it a shove, you have to round up. 4 or below, you let everything else go, you chop it off, and you keep the rounded digit in the example above the 4, you keep it the same. With compatible numbers, we have a little bit more leeway. We can round not necessarily to the closest thing, but we round to numbers that are going to make things easier. Now, this is especially useful if we're dividing, because by rounding with a little more leeway, we can round two numbers in a division problem so that we get one number divisible by the other, evenly divisible, without any remainder or fractions or anything like that. Using compatible numbers can also be really helpful when we're multiplying. Certain numbers like 5 and 2 and 10 and 11 and 100 are much easier to multiply by than by numbers that are very close. For instance, the difference between multiplying by 100 and multiplying by something close like 97, 98, 99 is a huge level of difficulty. So compatible numbers, we're given a little bit more leeway to pick numbers that are going to work well together. All right, enough about that for now. Next, we have clustering. Now, clustering is not actually mentioned in the chapter 1-4, but if you flip all the way into the exercises, the directions for numbers 43 through 46 talk about, let's see, 43 through 46 on page 23. Talk about a method called clustering. Now, clustering is great, but it only works for addition. And it only works when you're adding a bunch of things that are reasonably close together. Probably my favorite method of estimating, but again, it only works in very rare instances. So when we get a chance to use clustering, we definitely apply it. But if that won't work, a lot of the other problems we're going to do with either rounding, especially for addition and subtraction problems. We're going to do a lot of rounding. And for multiplication division, we're going to use a lot of compatible numbers. Now, there is a fourth method, and the fourth method is called Frontend Estimation, and I don't really have enough room to write anything about it right here, and that's probably the most complicated one. Now, the good news about front-end estimation is while it takes a little bit more effort and time, it the payoff, the benefit, is it gives us a very, very accurate estimate. All right, so let's continue on for a moment, and let's talk a little bit more about front-end estimation. Okay, I think you know what rounding is, and we've done that in class. Clustering is pretty straightforward, as are compatible numbers. And we'll have some examples for rounding and compatible numbers on the next slide. But right now, let's talk about front-end estimation. When you do a front-end estimate, the reason it's called front-end estimation is we really chop the front end of the number off, and we do that portion totally accurately. We add it just like we normally would. And I should say that right now. Front-end estimation is primarily used for adding numbers, usually decimals. All right, so to really explain this better, let's go ahead and put up some numbers. So there are 4 decimal numbers, and there are different ways to split the number into a front end and a back half. Where I'm going to split the numbers is I'm going to split them right down at the decimal points. Okay, and so to the left of the decimal, this is going to be the front end, okay, that we're referring to. And for the front end, we are just going to literally add up all of the ones digits. So 3 plus 6 is 9, 9 and another 9 is 18, and 3 is 21. So this portion right here, if I just add down this column, comes out to be 21. Now, for the back half, what I'm going to do with these numbers is we're going to take each of them and we're going to round them to the nearest tenth. You could think of this as rounding them to the nearest dimes. So 0.98 is actually going to round to 1.0, okay, because 0.98 rounds up, so it's really rounding to, let's think of this as money, as $1, okay. 0.49 is going to round to 0.5, 0.08 will round to 0.1, and 0.47 will also round to 0.5. Okay, no big deal. Let's go ahead and add these up. Now be careful, line up the decimals. So this is going to add up to, in the right, we're going to get 11, carry the 1, so we're going to get 2.1. Now the 21 in blue is an exact answer. The 2.1 in pink is an approximate answer. And now to put those together, we just add the two together, and we get an approximation of 23.1 for this problem. Okay? And I didn't draw this very well, but this wavy equal sign should look like this. It's an equal sign with 2 lines, and the way we read it is this symbol means approximately equal to. Now again, that's quite a bit of work for one problem, but we did add up 4 decimals, and our estimate of 23.1 is very accurate. It turns out that if I actually added these 4 numbers very precisely, either by hand or with a calculator, let me erase that, the exact value would have been 23.02. Okay, so our estimate of 23.1, let's go ahead and subtract here and see just how close we were, and you can see that we are within 8 100ths, or in other words 8 pennies, on a sum of about $23. From the real number, less than a dime. Okay, and often when we do front-end estimation, our estimate will come out even more accurate than that. Okay, so that's front-end estimation. So the 4 methods, once again, let's back up just a moment. Our 4 methods are rounding, using compatible numbers, clustering, and then finally front-end estimation. All right, so let's move on. Let's do a couple of examples. All right, so the first example we're going to look at is 5.05 minus 1.9. Oftentimes with a problem like this, it might just say in the instructions to estimate this. On the other hand, it might be a little bit more specific. It might say to estimate this by rounding both numbers to the nearest whole number first. Okay, where I actually pulled this problem, those were the instructions. Round these numbers first to the nearest whole number and then subtract. So what we're going to do is we're going to show our work. And the way we show our work for a rounding problem is we put the numbers that we round these to underneath. So we round 5.05 to 5 to the nearest whole number, and 1.9 rounds to 2. Now when we subtract, 5 minus 2 is 3. And if you want, you can put the wavy equals out front here, because at this point, this is where we rounded. So this is our rounded answer. Okay. Now sometimes a problem might ask us to find the actual difference and then to compare the 2 numbers. If it asked us to do that, we would have to line up the decimals again. Okay, put an extra 0 in there, and then go ahead and subtract. And we're going to do a little borrowing here. Okay, notice when I borrowed across it became 10. I don't need to borrow from that, so I don't need to do any of that 9 nonsense. 10 minus 9 is 1, and 4 minus 1 is 3, so I get 3.15. All right, that's a pretty good and quick estimate if the actual difference was 3.15. All right, let's continue on for a moment. Let's look at another example. Same instructions. Let's round both of these numbers to the nearest whole number. So 18.75 will be 19. And 93.346 will be 93, and that's the point where we rounded. Now if we add these two numbers together, you may or may not be able to do that in your head. It's probably safer to come over here and just do 19 plus 93, because there is a carry involved. 9 plus 3 is 12, and 9, 1, and 1 adds up to 11, so we get 112. All right, and both of those we're using rounding. All right, let's take a look at the next problem. 319.7 divided by 48.79. Now, as soon as you saw or I said divided by, the only strategy I want you thinking about is compatible numbers. Okay? So, in this case, we want to pick two numbers that are compatible. And what I like to do is look at both numbers together. What two numbers would work well? Well, 48.79 is pretty darn close to 50. And now, if I round 319.7 to a number that will be divisible by 50, the most logical one is just to round it to 300. Okay, now notice, that's a big round. We've chopped 19.7 off. But in the scheme of division, that's not such a big deal. And now we're going to get a nice, neat round. 300 divided by 50 is exactly 6. We don't get any weird decimals, and we get a useful estimate. All right. Were we to punch that same exact calculation into a calculator, 319.7 divided by 48.79, we get a quotient of 6.5525, and it goes on quite a ways. All right, so that's about 6.5, 6.6. So we're accurate to about a half a unit. And for a big ugly division, that's enough that we are going to be able to tell things like, did we put the decimal in the right place? We're going to catch obvious errors. Okay? And so the reason that we do all this estimating stuff in the first chapter is by being good at doing estimates, we're going to know when we've made a mistake and be able to catch it quickly. All right, so moving on, I'm just going to stop here and really thank you for coming back and watching this video after the fact. I hope this serves as a great resource and really helps you with all four of those estimating techniques, whether you're rounding, using compatible numbers. There was no example in the video of clustering, but we did do one in class, and that's pretty straightforward. And then most importantly, front-end estimation. That's probably the newest one for you all, and that's one that we'll practice. So make sure you're good at that prior to our test. But without further ado, I'm going to cut things off. Again, thank you for watching, and I will see you in class.